Today I am going to work out 5 problems in series parallel combination. The first problem is I have connected 10 resistance in series and parallel combination. In series circuit current is constant, in parallel circuit voltage is constant. First question is find the total resistance. Number 2, find the current through the 10 ohm resistor and also find what is the power dissipation in the 10 ohm resistor. Here the 2 and 3 are connected in parallel, 4, 5, 6 are connected in parallel, 7, 8, 9, 10. All the resistors are connected, 3 resistance, 3 part is connected in parallel. One is connected in series with this 1 ohm resistor. All are in ohms. First I have to reduce the circuit, then only I can easily compute the total resistance. These 2 and 3 are in parallel, therefore the total resistance is 1.2 ohms. Its resistance is 1.2 ohms, I have mentioned. And 4 by 6, 1 by R is equal to 1 by 4 plus 1 by 5 plus 1 by 6, then that is 0.61, therefore R is equal to 1.64. Similarly, I can compute the resistance 7, 8, 9 which are all in parallel, 1 by R reciprocal. Therefore, R is equal to 0.4, that is 2.08. 1 by R is equal to 0.48, R is equal to 2.08 ohms. Now I can redraw the diagram like this. This is 1 ohm. There are 1, 2, 3, 4 combinations here. 1 ohm, 1.2 ohm and 1.6 ohm and 2.08. These combinations. So the total resistance is 5.92. Therefore I can calculate the current I is equal to 50 by 5.92, 8.45 amps. So this is 8.45. So current towards the battery is also 8.45. Current entering the junction is 8.45. Current leaving the junction is 8.45. Once I know the branch resistances, I can easily compute the value of voltage drop. The total voltage is 50. The total current is 8.45. Therefore, I into R, this is 8.45. This voltage is 10.14 volts. This is 13.856 volt. This is 17.58 volts. So total voltage must be equal to the supply voltage. Here 8.45, 10.14, 13.86, 17. I will get 50. The problem is correct. Next is I have to find what is the current flow through the 10 ohm resistor. I will take this only because the current towards this junction is 8.45. I can connect this point in the 7 ohm, 8 ohm, 9 ohm or 10 ohm. Nothing will happen because the total current injected in the circuit is 8.45. The current leaving the junction must be equal to 8.45. I know the voltage across this unit. So that is 17.58. Therefore 10 divided by 17. That is 17. I is equal to V by R. V is 17.58. R is 10. Then I can find what is the total current. The total current is 1.76. 1.76 amps. This is 1.76 amps. Okay. So similarly, I can compute the value of current through the 9 ohm, 8 ohm, 7 ohm resistance. Now I have to find what is the power dissipation. So that is formula is I square into R. So I know. So 1.76. That is 1.76 the whole square into 10. That is equal to 30.98. The second problem is there are 8 resistors are connected in series and parallel combination. The question is find the total resistance in the network and what is the current flow in the 5 ohm resistor. What is the current in the 5 ohm resistor? So this is the 100 volt supply. 1 ohm resistance is connected. The 2, 3, 4 all are connected in parallel. Somewhat in this 5, 6, 7 it is just like a triangle. And here one resistance is connected in series with this. This is 8 ohm resistor. All are in ohms. 1 to 8. So first I have to identify which are all parallel and which are all series. Here this is a series. Here the total current is here make it as a branch currents. This naturally this part is a parallel circuit. Again another parallel circuit is here. This current will divide into I5 and I6. First I have to find the total resistance of 2, 3, 4 ohms because 3 are connected in parallel. 1 by 2 plus 1 by 3 plus 1 by 4 1.08 1 by R, that is value is 1 by R. Therefore R is equal to 0.93. Now here the 7 and 6 is connected in series. Even though it is connected like this, these two are connected in series. 7 plus 6, 13. The total resistance is 13. Just I redraw the diagram like this. 2, 3, 4 and this is 5, this is 7 and 6. I can draw as I like, but the connection should be correct. Now the total resistance is 13. The 13 and 5 is connected in parallel because this current is here I5 and I3. Therefore the total resistance is 3.61. Again I redraw the circuit. There are 1, 2, 3 combination. Therefore 3 resistance will play. One is a 1 ohm resistor, another is a 0.93, another is a 3.61, another is a 8 total. Therefore 1, 2, 3, 4 things. Therefore 1 plus 0.93 plus 3.61 plus 8 is equal to 13.54. The total resistance in the network is 13.54 ohms. First part is over. Next I have to compute the current. I can easily find the current. I is equal to V by R. Therefore this is 13.54. I will get almost 7.39 amps. I can again redraw the diagram like this. This current is 7.9 and 1 ohm, 0.93 ohm, and this is 5 point something like that. And my aim is to find what is the current flow in the 5 ohm resistance. So there are 3 resistors are connected in series. One is 8 ohm connected in series, 1 ohm and 3 ohm. These 3 resistors are in parallel with the 5. Therefore I have to calculate the total voltage drop. So the voltage across the 5 equal to 100 minus this drops. Therefore the 1 ohm resistance is 7.39 volts. And similarly 0.93, this is the current, this combination resistance is 0.93, the current is 7.39, this voltage is 6.87. The third is 8 ohm resistance. So the current here also 7.39 amps. Therefore 8 into 7.39, 59.12. So the total voltage drop across these 3 resistances is 73.38 amps, 38 volts. Therefore total voltage is 100. V is equal to 100 minus 73.38. The voltage across 5 ohm resistance is 26.62. Voltage across the 5 ohm resistance is 26.62. Therefore current I is equal to 26.62 divided by 5. I will get 5.32 amps. Current flow through the 5 ohm resistance is 5.32. Similarly, I can find what is the current flow through in the 13 ohm because these two are connected in series. 26 point, the same volt because even though they are connected in series, that is totally 13 ohms. 13 ohm and voltage is 26.62. I is equal to 26.62 divided by 13. I will get some current that is 2.08, no, 2.05. Therefore, the total current is 7.37. The total current, according to the resistance, total resistance 13.54. Voltage is 100. Current is 7.39. Here, this current is also 7.39. Here, I can also compute what is the current here and what is the current 5.32. That is 7.55 minus. That is what is the current? 7.39 minus 5.32 will be the remaining current. 2.05 will flow through the 6 ohm resistor. The third problem is, there are 8 resistors are connected like this as shown in figure. Find the total resistance and also find the total current. This is the third problem. This is a different type of problem. Then the voltage is given, 1 3 ohm, 2 ohm, 6, 6, 2, 12 and 2 and 4 is given. This is 4 ohms. So we have to identify which are all, first step is we have to identify which are all series and parallel circuit. Very simple. Here the current takes divisions. This is a parallel circuit. This is parallel combination. And this is parallel. Here this current flows through the 2 ohm resistance is same. This is a series circuit. Therefore, I reduce the circuit. The 2 plus 4 is equal to 6. The 6 is in parallel with the 12. Therefore, 12 into 6 divided by 18, that is equal to 4 ohms. Now I can reduce the circuit. This is 100 volts, 3 ohms, 2 ohms, 6 and here 6. And this combination will give 4, 2 plus 4 is equal to 6. The 6, 6 is both are in. There are 3 6. The 2 is 6 ohm, 6 ohm, 6 ohm. The two 6 ohms are connected in parallel. So already in the last class I told you the resistance values are same values are connected in parallel. Simply we can find the resistance. 6 into 6 divided by 6 plus 2. Instead of that we can simply divide it by 2, one resistance value. That is 3. Now this is another step. Again I will reduce it. This is 100 volts. The voltage, this is the 3 ohms is given, and this is 6, this is the 3, and this is 2. These two are in parallel. Therefore 6 into 3, 18 by 9, 2 ohms. Again these 2 ohm and 2 ohm are in parallel. Here because the current takes divisions. There is a branch current 2, 2. Naturally the total resistance is 1. 1 plus 3 is equal to 4. The total resistance is 4. This is 4. Therefore, the current I is equal to V by R. Voltage is 100. Total resistance is 4. I is equal to 25 amps. At 12 and 6, that is 2 and 4 are in parallel. The 12 and 6 is parallel, correct. 2 and 4 is not in parallel. This is series. First we have to combine these two. So the current flowing the 2 ohm resistance is same with the 4 ohm resistor. This is the exercise problem I have worked out. This is a very important university problem. Problem 4. It's a exercise problem in page number 32. BL Tereja, volume number 1. Using series and parallel combinations for the electrical network of the figure, calculate A. Current flowing in the branch AF. B. Potential difference across CD. All resistance are in ohms. First is, we have to find what is the current flowing in the branch AF. The second part is, what is the potential across 5 ohm resistors or CD? This is the question. In series and parallel combination, here the 9 and 5 are series. Therefore, I will redraw the diagram like this, the same diagram without the C and D and everything. I want to calculate the total resistance. So I remove the marks with A, B, C, D and everything. Simply this is the current, this is EAF. This only I can put. This is just this resistance is 1 ohm. I have to find what is the current here. Here there is no resistance in the original diagram. Just I draw this 1 ohm resistance like this. Now these two resistance are series. 9 and 5 are in series. So 9 plus 5 is equal to 14. 9 by 14. These 42 resistance are in parallel. I can redraw the diagram like this. This is 22, this is 1, 13, 18, 11, 14 and 14. This is 14 and this is also 14. The same thing, I redraw like this. Here these two resistance are parallel. 14 into 14 divided by 14 plus 14, that is equal to 7. Again I redraw the diagram like this: 24, 18, 11, 7. Again the 11 and 7 are in series, therefore the total resistance is 18. The 18 and 18 are in parallel, and the both resistance are in parallel, same value. 18 divided by 2, simply I will add 9. Again this 9 and 13, these two are in parallel, therefore the total resistance is 22. This is 22, this is 1, again this is 22, the same, these two 22 are in parallel. So the effective resistance is 11, the total resistance is 11, parallel, 22 into 22 divided by 22 plus 22, 11. This resistance is 1. Again the 11 and 1 is in series. The total resistance in the node is 12 ohms. Therefore, current I is equal to V by R, 24 by 12 is equal to 2 amps. Current flow in the network is 2 amps. In the branch AF, the first part is over. Part 1 is answer is 2 amps. It is exercise problem. So the answer is given, that is 2 amps, correct. We will look at the part 2. So what is the voltage across the 5 ohm resistor? That is the question. I will redraw the diagram like this. There are this 1 ohm resistor, here I am marking like this. This 22 ohm resistance I draw like this. This is 13 ohm resistance. This is 18 ohm resistance. This is 11 ohm resistance, and this is 14 ohm. This is 9 ohm. This is 5 ohm. So both the figures are correct. This figure is, this way also we can draw. Here first I know what is the current. Current is 2 amps. Therefore this is a 1 amps is the internal resistance of the battery, we consider. Therefore 1 into 2, 2 volts drop. Therefore 24 minus 2, that is equal to 22 volts. Here the 22 volt appear across this. This is 22. This is a 18 ohm resistor. The resistance here, the resistance is 22. The current towards this junction is 2. This is here 1. This is 1. So naturally the 22 volt appears across this. 22 divided by 22 is the 1 amps. Correct. Again this is 22. I have to find what is the voltage drop. 1 amps, 1 into 13 volts, correct. 13 volts. Here the total voltage is 22 volts. Here the 22 minus 13, that is equal to 9 volts. So the 9 volts across the 18 ohm resistance. Therefore current through the 18 ohm resistance is 9 by 18, 0.5. This is, here it is 0.5, here it is 0.5. Again I check the Kirchhoff's law. Current towards the junction is 1. Current leaving the junction is 0.5 plus 0.5, 1. The problem is correct. Now the 11 ohm resistor. So the 0.5 amps flows in the 11 ohm resistance. The total voltage drop is 5.5. So here the total voltage is 9. Here the total voltage drop is 5.5. 5.5, that is 9 minus 5.5, that is equal to 3.5 volts appears across in the 14 ohm resistor. Okay, here the current is 0.5. Therefore 3.5 divided by 14, you will get 0.25. This 0.25 goes in the 14 ohm resistance, and the remaining 0.25 goes to the 5 ohm resistor. Therefore, again I can check the Kirchhoff's law, current law, that is 0.5 towards the junction is 0.5, current leaving the junction is 0.25, and this also 0.25. So what is the voltage drop? These 5 ohms and 9 ohms are connected in series. Therefore 5 into 0.25, you will get 1.25 volts. The first part is the current we can calculate by reducing the network. We will find the total resistance and we can calculate the total current. Here, what is the voltage drop across the 5 ohm resistance R C into D? That is 1.25 volts. So this problem is available in page number 32, BNT, volume 1. The last problem is, in the circuit shown in figure, find the value of supply voltage V, so that 5 ohm resistor can dissipate 80 watts. In previous problems, supply voltage is given. We are finding a current in any particular resistance, any one resistor, or power dissipation, or total power. Here the reverse. We have to find what is the supply voltage. Only one value is given. Power dissipation in the 5 ohm resistance is 80 watts. Now we will work out the problem. Here 6 resistors. 1, 2, 3, 4, 5, 6. 6 resistors are connected in series and parallel. Here 4, 5, 6 are in series. And 2 ohm is connected with these resistors. Now I can redraw the diagram. Here I have to redraw the diagram like this. This is 1, 2, 3, 4, 5, 6. The power dissipation is given in the 5 ohm resistance is 80 watts is given. I square R is equal to 80. I square is equal to 80 by 5, that is equal to 16 amps. I is equal to 4 amps. So current flow through the 5 ohm resistor is 4 amps. The 4, 5, 6, 3 are connected in series. Therefore current flow in the 4 ohm, 5 ohm, 6 ohm is same. Hence I can easily calculate the voltage drop. 4 into 4, 16. 5 into 4, 20. 6 into 4, 24. Sum of the voltage drop, 16 plus 20 plus 24 is equal to 60 volts. The 2 ohm resistance is connected with this. Therefore, voltage appears in the 2 ohm resistance is 60. Current flow in the 2 ohm resistance is 30 ohms. Naturally, current towards the junction is 30 plus 4, 34. According to Kirchhoff's law, current towards the junction is equal to current leaving the junction. This is 30 plus 4, that is equal to 34. The next step is, I have to calculate the voltage, supply voltage or a source voltage. So here the current is 30 I have found. This is 34. That's 34. The current through the 3 ohm resistance is also 34. 1 ohm resistance is also 34. Here the 2 ohm resistance is 60. That is 1 into 34 plus 3 into 34 plus 60. Total voltage is 196. I have calculated the value 196 volt. I have to check whether this value is correct or not. Yes, it is possible, because here the 3 resistance 6 plus 4 plus 5 is equal to 15 ohms. The 15 ohm resistance is parallel with the 2 ohm resistance. Therefore, 2 and 15 are parallel. 2 into 15 divided by 2 plus 15, 17. 30 by 17 is equal to 1.76 ohms. So combination of these two will gives a 1.76. Therefore, this is 1 ohm, this is 1.76, this is 3 plus 4 plus 5, 5.76. Total resistance is 5.76. The source voltage is 196. Therefore, I is equal to V by R. 196 by 5.76, 34 amps. Problem is correct. Very important problem and very interesting problem. With this, I conclude my lecture. Thanks for listening.